I do want to take a moment to look at one of the harder problems in the lab manual. So what we see is a word problem about time, and it says the temperature in degrees Fahrenheit over a summer afternoon. But when we look at the timetable, we're looking at 12 p.m., which is noon, 1 p.m., 3:15, 4:30. All of these x values are not going to be able to be used in the way they are currently formatted. And that's just saying, like, when we looked at a average rate of change, the amount of time that has passed is what's important. So we're gonna alter our x values to look at maybe the hours after 12 p.m. And then that would change this to 0. And then 1 o'clock is 1 hour after. Now 3:15 is not 3.15 hours. It's 3 hours and 15 minutes. But that 15 minutes is out of 60. So when we think of 15 out of 60, and if you had even put that in a fraction, 15 out of 60, you're going to get 0.25 because that's a quarter of an hour. So it's 3.25 hours after noon. 4:30 is 4.5, 4.5 hours after, and then 6 o'clock would be 6 hours later. So our x values change. We could also have changed all of those to military time and just done this as like 13 o'clock, but you would still need to worry about these decimals, so 3.25, 4.5. Our y values don't need to change, so they can still be in temperature for degrees Fahrenheit. That doesn't matter. So let's look at our average rate of change from 12 o'clock to 1 o'clock and interpret this in context. So 12 o'clock is now our 0, which has an output of 78. 1 o'clock is 1 hour later, has an output of 82 degrees. And if we find our increase, so 82 minus 78 over 1 minus 0. And then we just work it out. 82 minus 78 divided by 1 minus 0, which is just 1, so we get 4. But we have to think about, what does that mean? So 4 was our output, which was degrees Fahrenheit, so 4 degrees Fahrenheit for every 1 hour that we're looking at. So in this case, let's interpret and say between the interval 12 o'clock to 1 o'clock p.m. The temperature, because that's our function, so the temperature increases, we have a positive rate of change, so it increases by 4 degrees Fahrenheit per hour on average. Wow, that just looks terrible, I can't spell. All right, so average, thanks. What is the average rate of change from 1 to 4:30? So 1 o'clock is still at 82, 4:30 we change, so it's now 4.5 with an output of 993. So we do 93 minus 82 over 4.5 minus 1. And again, you can use that fraction button, 93 minus 82, and then 4.5 minus 1, get your 3.14. And for this is something that we would need to estimate because we are talking about in a word problem. So let's change that to just 3.14, and you could do 3 decimal places. I'm just going to do 2 for right now. But it's in degrees Fahrenheit for every 1 hour. So between 1 o'clock p.m. and 4:30 p.m. the temperature, there's our function, so the temperature increases by 3.14 degrees Fahrenheit per hour on average. Now go ahead and try this one on your own if you haven't. And so you can pause the video and come back to this, but the average rate of change from 430 to 6, I'm going to do 4.593 and 691. If we do the average rate of change, we have 91 minus 93 and 6 minus 4.5. What we notice is this one's going to be negative. So 91 minus 93, there's our negative 2, 6 minus 4.5, 1.5. But we get negative 1.3333 repeating. So negative 1.33 degrees Fahrenheit per hour. So between 4:30 and 6 o'clock, the temperature, but this time the temperature is not increasing, it's decreasing because we have a negative rate of change. So the temperature decreases by 1.33 degrees Fahrenheit per hour on average. Okay. The last one, estimate the time interval when the temperature was rising the fastest. And so if we looked at that, we could try to figure out which one of these would have the greatest change in a certain amount of time. So I'm going to be looking at what's that smallest value. So 78 to 93 looks like a very big change over 4.5 hours. So let's see what that looks like. So 93 minus 78 over 4.5 minus 0. 93 minus 78. It's 15 over 4.5. It's only 3.333. So we saw a bigger rate of change with that first one from 12 to 1. Okay, so the fastest rise was from 12 o'clock to 1 o'clock.